Hello friends, welcome back to my channel. So today we are going to read the chapter number 11 of class 10 ICSE, that is calorimetry. As the name suggests, you can understand that calorimetry. What does calorimetry mean? The word calorie, from the word calorie we can understand it's a term related to heat, because we say that because we measure the heat in calorie. And metry word means measurement. So ultimately, if we say that the measurement of quantity of heat energy is known as calorimetry. So in this chapter, what are the things we are going to read? First, we will first read about heat, then we will read about temperature, we will read about heat capacity, then we will learn about specific heat capacity, and we will learn about its measurement of specific heat capacity and heat capacity. These are the numerical ones problems we will learn. So first, what is heat? First, for to understand heat, we have to first learn some things. That is, first is internal energy. What is this thing? What is internal energy? As we know, every body is made up of molecules. These molecules possess kinetic energy. Molecules possess the kinetic energy due to their random motion. Due to their random motion, these molecules possess kinetic energy. And they also possess the potential energy because the intermolecular attractive forces. So they possess both kinetic energy and potential energy. The kinetic energy is because of the random motion of their molecules, and the potential energy is due to the intermolecular force of attraction. These sum of potential energy and kinetic energy of the molecule is called internal energy. The sum of potential and kinetic energy is called internal energy. And total internal energy of all the molecules of a substance is called thermal energy. The total internal energy of all the molecules in the body is called the thermal energy. So I have made a clear flow chart of this, that internal energy of a body is the sum of potential energy and the kinetic energy. It is the sum of potential energy and kinetic energy is the internal energy. Now, what is heat? If we ask, if you ask that what is heat, what if I ask you that what is heat, what will be your answer? You will say that yes, it is a form of energy. Yes, yes, it is a form of energy. Heat is a form of energy. Heat is a form of energy, just like light, sound. Heat is also a form of energy that flows from a hot body to a cold body. Heat transfer heat flows from where to where? From a hot body to a cold body when they are kept in contact with each other. Suppose this is one of the I made. This is the hot body and this is the cold body. So heat will transfer from this hot body towards the cold body, and this is the point when these two are kept in contact with each other. Now, from the I have told you that what is calorimetry, that is the measurement of quantity of heat. Measurement of quantity of heat is known as calorimetry. So previously I have already told you. Now, unit of heat energy. What are the units by which we measure the heat energy? In SI unit, since heat is a form of energy and all the energies have SI unit joule, so his SI unit of heat is also joule. And most common unit which we use to measure heat is calorie. Uh, okay, so let's move on to the next slide. Let us change the background to black. Yeah. So, what is calorie or what is 1 calorie? 1 calorie, simply if you tell that 1 calorie is the amount of heat energy required to raise the temperature of 1 gram of water by 1 degree Celsius. So what is 1 calorie? 1 calorie is the amount of heat energy required to raise the temperature of 1 gram of water by 1 degree Celsius. But it is not actually the current, means not precise definition. The precise definition or the 15 degrees Celsius calorie rule, that is a precise definition of calorie is what? 1 calorie is the heat energy required to raise the temperature of 1 gram water from 14.5 degrees Celsius to 15.5 degrees Celsius. Ultimately, these and this is almost same because this is by 1 degree Celsius, and if we see here from 14.5 degrees Celsius to 15.5 degrees Celsius, that means what? By 1 degree Celsius only. So this is a precise definition. This is a general definition. Mm. And here is the relation between calorie and joule. 1 calorie is equals to 4.186 joule, and it is precisely means approximately it's 4.2 joule. For mathematical calculations, we will use 1 calorie equals to 4.2 joule. For mathematical calculations, we have to use this. But accurately, it is 4.186 joule. And 1 kilocalorie is equals to 1000 calorie. Like 1 kg is equals to 1000 gram. That is only 1 kilocalorie equal to 1000 calorie. And so we know 1 calorie equal to 4.2 joule. Then 1000 calorie equal to 444.2 into 1000. That is 1 kilocalorie is equals to 4200 joule. This is the derivation of this. What do you mean by 1 calorie? 1 kilocalorie? 1 kilocalorie is the amount of heat energy required to raise the temperature of 1 kg. You have to raise the temperature of 1 kg water from 14.5 degrees Celsius to 15.5 degrees Celsius. So this is the definition of 1 kilocalorie. These definitions are not frequently asked generally in board exams, like what is 1 calorie, but it's necessary for your MCQ part. So have a brief idea about these things. Next, we will go to understand temperature. So let's move into the discussion of temperature. Temperature. Temperature is a parameter. Temperature you have learned. We are very much familiar with the word temperature. We say that today's temperature is very high during summer days, or in winter days, we say today's temperature is very low. So, what is temperature? Temperature is just a parameter. Temperature is just a parameter which tells us the degree of hotness or coldness of a body. So, what is temperature? Temperature is just a parameter which tells us the degree of hotness or coldness of a body. How much how much hot this body is or how much cold is the body is. Temperature tells us that only. And it is the temperature that determines the direction of flow of heat when two bodies at different temperature are kept in contact. Yes, a body heat will transfer from a hot body to cold body. Hot body means what? High temperature to a body kept in contact in low temp cold body is high temperature to low temperature. Heat will flow from high temperature to low temperature. Now, when two bodies acquire the same temperature, or when two bodies have the same temperature, then no heat transfer takes place. Okay, when two bodies, suppose this is 35 degrees Celsius and this is 10 degrees Celsius. It will start transferring from 35 degrees Celsius to 10 degrees Celsius. Suppose at a point, let us uh, say that, at a temperature 22.5, both acquire of this is losing it, then this is gaining in, and at a point 22.5 degrees Celsius, both the body having the same temperature. This body also acquires 22.5 degrees Celsius by losing it, and this body also acquires 22.5 degrees Celsius by gaining it. Now both the bodies have same temperature, so there will be no heat transfer, and this is known as the equilibrium temperature. We will learn about this later in this part. Now let us read about units of temperature. SI unit of temperature, as we know, it's Kelvin, and most commonly we use Celsius. And the relation, obviously, you have to learn, that is temperature in Kelvin is equal to 273 plus temperature in degree Celsius. Hence, to find the equivalent temperature in Kelvin scale, you have to add 273 with that of the given Celsius temperature. You will get the equivalent Kelvin temperature. Precisely, it is 27.273.15, but we for mathematical calculations, you can use this 273 also. And absolute zero, that's 0 Kelvin, is minus 273 degrees Celsius. In this temperature, all the molecular motion ceases. Practically, it is impossible to attain this 0 Kelvin temperature because minus 273 is very much lower. It is practically impossible to attain this temperature. Now, for example, now, for our understanding, I have given one example, that is convert 37 degrees Celsius to equivalent Kelvin temperature. So I have written, you will write given temperature in degrees Celsius, given 37 degrees Celsius. We know that is to convert in equivalent Kelvin temperature, we need to add 273 with the degrees Celsius. So 273 plus 37, we are getting 310 Kelvin. So 37 degrees Celsius is equivalent to 310 Kelvin. Vice versa, if we suppose the temperature is given in 310 Kelvin, we need to find the equivalent Celsius temperature. We know this formula, temperature in Kelvin equal to 273 plus temperature in degrees Celsius. So if we by equating this equation, temperature in degrees Celsius equal to temperature in Kelvin minus 273, that is, it is coming again 37 degrees Celsius. So in this way, you can change temperature from Celsius to Kelvin or vice versa. Let's move to the next slide. Now we are going to read about some of the factors affecting the quantity of heat absorbed. So quantity of heat absorbed depends mainly on the three factors. Quantity of heat absorbed, that is Q, depends mainly on three factors. Number one is mass of the body. Second is increase in temperature of the body, and third one is material of the body. Mass, mass of the body, increase in temperature of the body, and material of the body. Mass, the heat absorbed is directly proportional to mass relation, so you have to also understand. heat absorbed is directly proportional to the mass. That is, if a body is having more mass, it will absorb more amount of heat energy. It is directly proportional. The amount of heat energy absorbed is directly proportional to the increase in temperature. That is, Q is directly proportional to delta T. It means if rising temperature is more, then the heat energy absorbed is also more. It also depends on the material of the body. That is, it's called the specific heat capacity. We will learn it in details. And this is also directly proportional to the heat absorbed. That is, Q directly proportional to C. More the specific heat capacity of a body, more is the amount of heat energy absorbed. And this is a very famous difference between heat and temperature. You have to learn this very much carefully. Questions may come, that is, state the difference between heat and temperature. Heat is a form of energy which flows from a hot body to a cold body when kept in contact. And temperature is a parameter which determines the direction of flow of heat. It's SI unit is joule and is SI unit is Kelvin. And it is measured by the principle of calorimetry and it is measured by a thermometer. So this is very simple. You can take ideas from this, or you may use your textbook for the difference. Acha, now from this, that is one equation number 1, 2, 3. If we combine this, we can write what? Q is directly proportional to m delta T, where m is the mass of the body and delta T is the rise in temperature. And Q is equal to C m delta T. C is the what? C is the constant. C is the constant. C is the constant. And after all, this formula comes as Q is equals to mc delta T. Since Q is directly proportional to mass and Q is directly proportional to degree rise in temperature delta T, so we can write Q equals to Cm delta T, where C is the constant and C is the specific heat capacity. So this formula comes Q is equals to mc delta T. This formula is very much important. Later, this formula will be needed to solve the numericals based on this calorimetry. So let's move on to the next slide. Now we are having heat capacity. Heat capacity. Heat capacity or thermal capacity denoted by G dash. Heat or thermal capacity of a body is the amount of heat energy required. It is the amount of heat energy required to raise the temperature of a body by 1 degree Celsius. To temperature of a raise the temperature of the body by 1 degree Celsius. Practically, in this chapter, we will say that delta T degree Celsius is equals to T Kelvin. Okay, means if we write that if we measure the temperature Kelvin or in Celsius, both we will say as equal. So I have written by 1 degree Celsius or 1 Kelvin. So heat or thermal capacity of a body is the amount of heat energy required to raise the temperature by 1 degree Celsius or 1 Kelvin. It is denoted by C dash. Mathematically, heat capacity C dash is equal to amount of heat energy supplied is Q by rise in temperature, that is delta T. So this formula comes as C dash equals to Q by delta T. Very much important formula. PVI for this formula is very much important. Q C dash is to Q by delta T. Q is what? Q is the amount of energy supplied and delta T is the rise in temperature. Now unit of heat capacity. Amount of energy is what? Joule. Rise in temperature Kelvin. So SI unit is joule per Kelvin. Other unit calorie per Celsius. 1 kilocalorie per degree Celsius is equals to 1000 calorie per degree Celsius. So 1 kilocalorie is equals to 1000 calorie. 1 calorie per Kelvin equals to 4.2 joule per Kelvin because 1 calorie equals to 4.2 joule. Now, a question comes that what do you mean by heat capacity of an object is 30 joule per Kelvin? It means that 30 joule is the heat energy required to raise the temperature of the body by 1 Kelvin. So it 30 joule per Kelvin means the heat energy required is 30 joule to raise the temperature of the body by 1 Kelvin. So this question may come in exam. You may write from this. So let's move to the next slide. Here we will read about specific heat capacity. It is also a very interesting part of this chapter, specific heat capacity. Specific heat capacity is nothing but the amount of heat energy required to raise the temperature of unit mass. Heat capacity of means heat capacity is the whole body. Raise the temperature of the whole body. Specific heat capacity means that raise to raise the temperature of a unit mass of that substance by 1 degree Celsius. You may say 1 Kelvin. So C is equals to what? We may say amount of heat energy supplied Q by mass, that unit mass, that is M, into rise in temperature delta T. So from here this comes C is equals to Q by M into delta T. From here we can say that what C is equal to C dash by, because C dash is equals to Q by delta T. C Q by delta T we can write as C dash by M. So specific heat capacity is formula. We have got two formulas of specific heat capacity. This is the number one formula and this is the number two formula. There are two formulas for specific heat capacity. This one and this one. Specific heat capacity is heat capacity, that is C dash by mass of the body M. Unit of specific heat capacity from a joule by Q. Amount of energy unit joule, mass is what? Kg, temperature what? Kelvin. So it's coming joule per kg per Kelvin or joule per kilogram per Celsius. So it's a joule per kilogram per Kelvin or joule per kilogram per Celsius. It's the relation you have to read. If note is given that if specific heat capacity of copper is 0.4 joule per gram Kelvin, this means what? This means it is heat energy required to raise the temperature of 1 gram copper. What is 1 gram copper by 1 degree Celsius is 4.2 joule. Understood. So this is the specific heat capacity of a body. Uh, so next, let's move on to the difference. There's a good difference between heat capacity and specific heat capacity. Heat capacity is the amount of heat energy required to raise the temperature of entire body. Here the keyword is entire body by 1 degree Celsius. And in case of specific heat capacity, amount of heat energy required to raise the temperature of unit mass of the body. Unit mass of the body by 1 degree Celsius. So here the keyword is entire body and here the keyword is unit mass of the body by 1 degree Celsius. Its SI unit is joule per Kelvin or joule per degree Celsius, and its SI unit is joule per kg per Kelvin or joule per gram per degree Celsius. Heat capacity depends on both the nature of the substance and mass of the body, and specific heat capacity does not depend on the mass of the body. It is the characteristic property of the body. And one thing I forgot to tell, that specific heat capacity is the property of substance or the material. It will not change. Like if a suppose I have taken a copperware, copper vessel, and a copper container. The specific heat capacity of all these three things, that is wire, vessel, and container, will be the same because it is made up of copper. The, that is the same substance or same material. So specific heat capacity for three of them will be equal. But heat capacity will for the three will not be equal because it depends on nature of the substance and mass of the body. For the three, mass will be different for each of them, and so the will be different. Whereas specific heat capacity will remain same for three of them. These are the values of some specific heat capacity you need to uh, memorize. As for ice, it is 2.1 joule per gram per Kelvin. For water, it is 4.2 joule per gram per Kelvin. And for copper, it is 0.4 per joule per gram per Kelvin. And here I have shown a simple device of calorimeter. Calorimeter for this, we have to take a thin copper sheet. This is the copper sheet. This is a copper sheet. The internal part is a copper sheet, and we have to take it inside a wooden jacket. This is a wooden jacket. This part is a wooden jacket. This wooden jacket, we have to keep the copper sheet, copper vessel inside the wooden jacket to prevent heat loss by radiation. The space between this copper sheet and the wooden jacket is to be filled with insulating substances like wool or cotton, which will not conduct heat, and this will help us to uh, reduce the loss of heat energy by conduction. And the mm, mouths to be closed by these wooden lids. These wooden lids, the mouth needs to be closed so that heat energy is not lost by convection. So the three way of his heat loss is adjusted. Now we have to take the thermometer, and there is a stirrer, and this is the whole structure of the calorimeter. And there are some questions of why calorimeter is made up of thin sheet of copper, because copper is a very good conductor of heat, so cell will soon acquire the temperature of its content, and copper has low heat capacity. Understood? Copper has low heat capacity. Let's move on to the next slide. And here ultimately comes the principle of calorimetry. Okay, wait, let me zoom it. Yeah. This is the principle of calorimetry or principle of method of mixtures. That is, heat energy lost by hot body is equals to heat energy gained by cold body. This is the principle of calorimetry. Only this is the heat energy lost by hot body is equals to heat energy acquired or gained by the cold body. And this principle is based on the law of conservation of energy. Mathematical statement: suppose this is a hot body whose mass is m1, specific heat capacity is c1, and initial temperature is t1. And here I have taken a cold body whose mass is m2, specific heat capacity is c2, and initial temperature is t2. And these two are kept in contact with each other. Now this hot body will lose heat, and this cold body will gain it. And a point comes, that is theta, a temperature comes theta. After losing heat, this hot body acquires a temperature theta, and after gaining heat, this cold body acquires a temperature theta. After that, there will be no transfer of heat since both the body have same temperature. So we can say that heat lost by the hot body, that is Q1 from the formula, it's M1 MC delta T. It's M1 into C1, M1 into C1 into T1 minus theta, and heat gained by cold body is M2 C2 theta minus T2, since theta is higher and T2 is lower, so theta minus T2. So by principle of calorimetry, we can say that Q1 equal to Q2. So M1 C1 T1 minus theta equal to M2 C2 theta minus T2. Understood? So this is the first part of the chapter. Next day we will discuss some illustrative examples and we'll read about the latent heat and the rest part of the chapter. So I hope you have understand and have got an idea about the chapter. So thank you. Bye.